So let's check the rules for the atomic structure as we took them. The atomic number equal the number of protons. The number of protons equal the number of electrons. And the mass number equal the number of protons plus the number of neutrons. While the number of neutrons equal the mass number subtracted by the number of protons. So if you know the mass number and atomic number, you know the composition of this element. So let's exercise about this. We have a problem here, and we have two numbers, the first one on the top and the second one. We know that this one called the atomic mass and this one called the atomic number. So find the number of protons, the number of neutrons, the number of electrons, atomic number, and the mass number. So let's start with the first one. If I want to know the number of protons, I must check the smallest number, which is 35. Excellent. And the number of neutrons, to get the number of neutrons, we must subtract 35 from 80. So 35 from 80 equals 45. So the number of neutrons will be 45. The number of electrons will be equaling the number of protons, so it will be 35 too. And the atomic number is this number, the 35, and the atomic mass number is 80. Excellent. Let's exercise on this too. If you have an element has an atomic number of 34, a mass number of 78, what is the following? So let's take it. The number of protons, we know that the atomic number equals the number of protons, so this is the number of protons. The number of neutrons, to get it, we must subtract 34 from 78 to get the number, so we will have 44. Excellent. The number of electrons equal the number of protons, so it will be also 34. And complete the sample, we must search about this in the atomic in the periodic table to get this element, what the name of this element and the symbol of it. Okay, exercise 3. If an element has 78 electrons and 117 neutrons, what is the following? So what will be the atomic number? If we have 78 electrons, so this means that the electron atomic number also is 78. Excellent. And the mass number will be, we said that the mass number equal the protons plus the neutrons. So we have neutrons here and we have also electrons which equal the protons. We must add 78 to 117 to get the mass number. Excellent. The number of protons equal the number of electrons. Excellent. And complete the sample. Also we have to find this in the periodic table. And here we have also different examples. I want you to practice on them. We have different elements. You saw the symbol of them here, and some of them I'm giving you the atomic number, some of them I'm giving the electrons or the neutrons to get the missing part. So you must practice on this to get the missing part. And I put a periodic table for you. You can check on it, and if you zooming it, you will find that there is two numbers. The first one on the top, which considered as the atomic number, the smallest one, and the biggest one is the mass number. So if you want to search about anything, like here if I'm talking about the carbon, this is the name of the element and this is the symbol, which is C. The atomic number is 6 and the mass number is 12, and so on, so you can find any element you want from here. Let's move to the last part of this lesson, which will be about the isotopes. What's the meaning of isotopes? Isotopes is atoms that have the same number of protons and different number of neutrons. So this atom has different number of neutrons. Since isotopes have a different number of neutrons, the isotope has different mass number too. So maybe we have different the same atom, but it has two different mass number. So you must know that this is isotopes because the number of neutrons are different in this case. Isotopes are like, or still chemically like, because they have the same number of protons and electrons. So they have the same chemical property as each other. Examples of them like the hydrogen. Sometimes I'm finding hydrogen with one proton, and sometimes you find it with one protons and one neutrons in the nucleus, and sometimes you find inside the nucleus one proton and two neutrons. So in this case, if I don't have neutrons here, this means that the mass number equal 0, 1 equal 1, sorry, because this will be there is no neutrons here. While here, if I'm asking you about the mass number, if it has one proton and one neutron, so this means that the mass number is 2, as you can see. Here, the mass number is 3, so we have 2 neutrons while we have only one proton. So maybe the same atom like the hydrogen has different isotopes. Also the helium, sometimes it comes with one neutrons and sometimes it comes with two neutrons, and the lithium so far and so on. So when the number of neutrons become vary or changed for the same atom, this is called isotopes. Isotopes are atoms of the same elements with different masses. So as you can see in the carbon here, all the atomic number is 6, so the number of electrons and protons doesn't change, while the number of neutrons change because the mass number of this carbon is changed. So this is the isotopes examples. Isotopes have different number of neutrons. Okay, so let's naming them. We will put the mass number. If you want to draw it or write it, we have to put the mass number after the name of the element. The carbon 12, so this means that the mass is 12. The carbon 14, so this means that the mass number is 14. Uranium 235, so this means that this is the mass number of uranium, which represent the isotope. Thank you for watching, and to be continued inshallah.